Hello all, welcome to Excel Academy. So today we are doing another video based on the same thing, the same diagram, but this diagram is something different than that. See, you had one, or I can say the dependent source over here, but here there is a resistance and dependent source is shifted to over here. And in this problem, you don't need what? You don't need Kramer's rule. Just a minute. You don't need Kramer's rule, you directly get the resultant. Fine, this is what is one thing that you need to understand. And let us start solving with respect to this particular problem. So in this particular problem, I'm sorry, you can see that there is four nodes, right? Just a minute. I'll take this as A. Hmm. Okay. So here, so this is one node, one node and one node. Why these are nodes? Because here this and this points, that is the end of this resistance, the start of this resistance, the positive of this dependent sources joining, connecting A. Fine, here B. So it is the start of this resistance, this particular, and this positive of this particular is connecting to one point, and here this particular is connecting to one point, that is this is positive of the current, and this is the end of the resistance, and the this point of the resistance is connecting to this one point, and here also there is a this negative of this particular, positive of this current, as well as this line of the resistance is connecting to this point. Fine, I guess you will understand how to start with the node. Fine, how to identify the nodes and all. So now let me come to supernode. So if I come to supernode, I told you that this is B and D is forming a one supernode wherein E is my ground state. So that is why I can say that my B and E are what? B and D are supernodes, but what happens is that your E is a ground node, so therefore I can say that your VB is equal to A2. Fine, A2, positive to negative, this positive we are considering, and it is A2. Fine, that is what we are trying to tell. We are just trying to tell that as there is an E which is in ground state, so you cannot take that as a supernode. Directly you can take the value of VB as A2. Fine. Next thing is you are going to find the supernode. This supernode is A to D supernode first. We'll apply KCL, and here you can see that it is 6I1. So this is I1. So what is your I1? Your I1 is flowing in this direction. So I can say that I1 is equal to VB minus VC divided by 2. Right? If it was flowing in this direction, it is coming from here. So if it is try to flowing in this direction from C, it is coming to, it's going to B. But here you can see this direction, it is telling that from B it is going to C. So you're going to take VB minus VC divided by 2. It is not VC minus VB by 2. Fine. This arrow mark is stating that from B your current is going to C. Fine. This arrow mark is going to state that from C your current is going to B. So therefore it is therefore for this it is from B the current is going to C. So therefore it is VB minus VC divided by 2. Fine. Yes. So now we can take the diagram. So let us consider my equations, nodal equations of A. If I consider my node equations of A, I can tell it as VA minus VB by 2 plus VA by 2. This is 2 ohm, students. I haven't written it. I'm so sorry. Fine. Okay. VA by 2. And here what's that going to happen is this third line is what I can say my supernode. Fine. My supernode, that is I have my voltage, so I'll neglect this. We'll construct a separate equation for this. Fine. Now here if you consider with respect to D, so for D here you can see that this is one voltage, this is dependent source, or I can say my current dependent voltage source, CDVS. This is current dependent, this is voltage source. Fine. How we can identify is that you need to identify with respect to V and I that is given to you in the question. See here it is 6, either V or I. If it is I is given and here voltage source is given, you can say that this current is dependent upon this voltage. That is why I say current dependent voltage source. You should not look at this. This is voltage source, I understand, but whatever here it is given, here if it is V is given, then it is voltage dependent voltage source. Here if it is I is given, then it is voltage current dependent voltage source. Fine. If it is I given here and I given here, it is current dependent current source. If there is a current given here and a V given here, it is voltage dependent current source. Fine. This one you are going to look at. First, this one comes into consideration. As this is current and this is voltage, we say current dependent voltage source. As this is voltage, if you consider that this is voltage, that is V, so you get it as voltage dependent voltage source. As this is a current source, and if you get V, you can say that first it is voltage which is depending upon current. Like that you're going to identify. Fine. Yes. So next what I can say, just a minute student. So here it is, this is what I can say, my what I can say, that is the dependent source is present. So that is why you are supposed to neglect this. We are going to make a separate equation for this. I'm so sorry. You're going to make a separate equation for this. And here also there is a current, so we are going to equate it to the other side. And here only this one we are going to take it into consideration, wherein it is Vd minus Vc divided by 2, which is equal to 3 Vc. Fine. Yes. So now if you consider, so this is Va by 2, 0.5 Va, and this is minus VB, that is minus how much? This is VB is equal to 8, as we all know that, and it is minus 4, it is plus. So once again it is 0.5 VA plus, so this is 0.5 VA, and this VA divided by 2, 0.5 VA. This VA minus VB by 2 was VA by 2 minus VB by 2. So this is 4 because this is 8, as you all know, here it is 8, and this is VA by 2, 0.5. This is what I can say, my plus. What you can say it is that is your VD by 2 minus Vc by 2. Let me write it like that only. So I get my resultant as what? I get my resultant as 3 Vc here. That is the current, whatever here we are going to equating it. Fine. So now next thing what you're supposed to do is that you're going to take what I can say, shift this to this side. Right? This is Vc, and here also it is Vc. So we are going to shift it to this side. So if I do that, and if I simplify this and this, 0.5 plus 0.5 is equal to Va. Right? It is Va minus 4 plus Vd by 2. What I can say, it is equal to 3 Vc plus Vc by 2. What? 3 Vc plus Vc by 2. Fine. So then if you consider this, so you're going to get the resultant as Va minus 4 plus Vd by 2, which is equal to, so this is 2, so you're going to get it as 1 into 2s are, so 2 3s are 6 Vc plus Vc, which is equal to 7 Vc by 2. Fine. You got it as 7 Vc by 2. Fine. So now what I can say, we are going to shift again this particular to this side and 4 to this side. Fine. So that you're going to get it as Va plus Vd by 2 plus it is minus 7 Vc divided by 2, which is equal to 4. Fine. You got it. So see here, this equation you got to know how to construct. Fine, I told you how to construct this equation, right? This is Va minus Vb by 2. This is Va by 2, and this is a dependent source wherein we are going to construct an equation later. And for D node, I can say that this is also dependent source, so we are going to make an equation the next in the next coming. And here this is one current source wherein we are going to equate it. You are going to write in the equal section. I'm so sorry, in the equal section. And this only this D and C is present, wherein we are going to make an equation for this, that is Vd minus Vc by 2. So that is equal to 3 Vc. So we did all this substitutions, mathematical I'm sorry, mathematical substitution. So you understood how did we do it? Fine. Yes. So now here, this is what is my, now I'm supposed to take LCM, 2 and 2 LCM, right? 2. So this is 1 into 2, and this is 2VA minus VD minus 7 VC, which is equal to 4. So now I shift it over here. I get it as 2VA minus VD minus 7 VC, which is equal to how much? It is equal to 8, right? 8. And now, so we are going to get this equation number 1. Okay, so now let me construct a node C equation. Fine. So we did node A and node D, right? Okay, so now let me construct the equation for node C. Fine. Yes, node C equation we are going to construct. Just a minute. For node C, first of all, before going to notes, you need to understand how this equation is taking place. So we have already done one problem with respect to this and a basic ideology with respect to this. So please do try to understand that particular and come back to this problem. Fine. I told you that I would be sharing the link in the description box. I'll be doing it today without fail. Fine. So please do try to watch those two videos and come back to this video. Fine. Yes. So this you understood how, and this all process I guess you understood. So let me come to here. So for node C, it is what I can say, VC minus VB divided by 2 and VC minus VD divided by 2, which is equal to 4. Fine. Yes. Which one? VC minus VB by 2. VC minus VD by 2, which is equal to 4. Right? Yes. Okay, this is also 2 plus. It is equal to 4 ampere. Fine. Now here, let us try to substitute 8 over here. And this is VC by 2. Just a minute. Okay, so sorry for the distraction. VC by 2 minus VD by 2 plus VC by 2. So that is minus 8 by 2, which is equal to 4. Here it is equal to 4A. Fine, ampere. So this VC by 2 and this VC by 2, that is 0.5 VC, 0.5 VC will become equal to VC itself, right? Yes. So if it becoming VC itself, so we can write it as that is VC plus VD by 2, which is equal to what I can say 8, right? That is how it is 8. It is because, so this is minus 4 with 4. So this is ampere, you can neglect. You need not to write ampere here. Okay. So this is minus 4 will become get shifted to here. So it is 4 plus 4, which is equal to 8. Fine. Yes. Okay. So now here you can see that. So now it is equal to 8, or what I can say my what it is, here you are trying to take LCM, so here also it is 2. LCM is 2, wherein 1 into 2s are 2, that is 2 VC plus VD by 2, which is equal to 8, or what I can say 2 VC plus VD, which is equal to 16. This is equation number 2. Fine. Yes. So now here this is equation number 1 and this is equation number which one? This is equation number 2. Fine. Yes. So now let us try to solve the just a minute. Let us try to solve the next one. So my next equation is nothing. This one, that is VA minus VD is equal to 6I. Fine. Okay. So always understand this particular super node. In the case of super node, you will be having two super nodes. You construct an equation for the two super node. The very first thing. The second thing, you are going to consider nodal equation for one single node, and then you are going to construct equation for this particular. Try to understand how the problem goes. Fine. For each and every problem in super nodes, you have two super node with respect to two nodes are supernode with respect to that problem, so you're going to construct a supernode equation for the two nodes. Then you're supposed to come back to the very first node, that is, which is a single node, which is not a supernode. That for that node you're going to construct an equation and then come back to this equation, that is Va minus Vd is equal to 6i1. So what is my i1? I told you my i1 is flowing in this direction, so it is Vb minus Vc by 2, right? I'll even substitute that. So it is Va minus Vd is equal to 6 into Vb minus Vc divided by 2. Fine. So now I know what is my Vb. My Vb is 8, right? So let me write. So Va minus Vd is equal to, that is 6 into 8 minus Vc by 2. So now this is 2 ones are 2 threes are. So I'm writing each and every step, because you will get to know why I'm writing each and every step. Okay. So here it is Va minus Vd is equal to 3 into 8 are 24 minus 3 Vc, right? So now I'll shift this over here, wherein I get Va minus Vd minus 3Vc, which is equal to 24. Fine. Yes. So now let me take this equation as 3. So therefore now let us try to solve this equation now. Okay. So just a minute, students. So now we are trying to multiply this with what? We are trying to multiply this with 2. Fine. Okay. So let me multiply this with 2. So you get 2Va minus 2Vd minus 6Vc, which is equal to 48. Fine. So now this is what is my simplified equation number 3. I'll tell you why we multiplied this equation with 2. Okay. So now what is my first equation? My first equation is this equation. Fine. I'll take this equation and the third equation, and I'll get one more equation called as 4. Fine. I'll take my first equation. My first equation is stating 2Va minus Vd minus 7Vc, which is equal to 8. And my second equation is 2Va minus 2Vd minus 6Vc, which is equal to 48. Fine. So now if I can take, this is minus, so which is 0. And this is plus, what I can say, my 3Vd. No, this is Vd itself. Fine. This is Vd. Just a minute, students, I'll clarify. I'm so sorry. So this is just a minute. So sorry for the distraction, students. Here it was plus Vd itself. We did not write that. So this is plus and this is plus. Okay. So here we missed a plus sign. Okay. So here it is plus Vd itself. So then it becomes plus. So here it is 3Vd itself. I was right. Okay. So it is plus 3Vd. And here this negative, here it is positive. So 7 minus 6 is what? 7 minus 6 is what I can say, minus Vc, right? Which is equal to how much? It is equal to, so this is minus, so it is minus 40. Fine. I guess you understand things in a better manner. So just a minute, students. I'm once again sorry for the distraction. Yeah, here it is positive. So here if this negative is going to shift out here, so if you shift minus 3Vc to this side, it is positive. So here also it is positive, so then it becomes minus, so it is plus 13Vc. Fine. I guess you got it in a clear manner. So I'll repeat it. Here it was positive already, so we missed that positive here. And here what was that going to happen is this minus 3Vc, if you shift it to here, you will get plus 3Vc. So this is plus 3Vc, and here this plus 3Vc into 2, 6Vc. And here it is plus 6Vc when it's becoming minus. So now it will become minus 13Vc. Fine. Yes. So you get it as 3Vd minus 13Vc, which is equal to minus 40. Fine. I guess you got it. This was a plus Vd, which was already there. We missed it. And here when you shift minus 3Vc to here, you get plus 3Vc. Okay. Yes. So now there small things happens. I'm so sorry for the distraction. Okay, now this is equation number 4. So why we constructed equation number 4 like this? See here, my equation number 2 is having only two variables. So if I get my equation number 4 as three variable, then you can't solve, right? You can't solve that. Can you solve an what I can say equation that is which is having one is two variable and one is three variable, which is not what I can say same. There's something different. You can't solve, right? You can't solve two equations having a different number of variables. Fine, it should be having same number of variables. If this is three variable equation, this equation should be also three variable equation. So if the equations numbers are different, so the number of variables are different, so then you can't even solve. That is why we just designed it in such a way that we just designed this particular equation in such a way that so you are going to get an equation number 4, wherein that equation number 4 is a two variable equation when it is going to satisfy this equation. So when it is going to satisfy this equation, so for when you take this equation and this equation, you try to solve, you get VC and VD. Fine, easily. Okay, so now when you try to solve 2 and 4, equation will be sorry, resultant, I'm sorry, result will be is equal to, that is your VC is equal to minus 8 by 7, VD is equal to minus 128 by 7. So this one you can solve it in calculator. I have already did for practice. See here, you can take this C, this is 2, minus 1 is 16, minus 13x minus 3y, which is equal to minus 40. If you take this in the calculator, you get the resultant. See, you get the resultant. See a resultant, x is minus 8 by 7, y is minus 128 by 7. Okay, and then here if you substitute this in where you're supposed to substitute, you're supposed to substitute in what I can say equation number 3, which is equation number 3, this one. If you try to substitute this in equation number 3, so if you check your equation number 1, yeah, you can do it in either of the equations, so you get the resultant. Fine, so let me do that. So let me substitute VC and VD in equation number 3. We get what? Your VA is equal to, directly substitute VC and VD. So what I can say, you get it as VA is equal to 9.1435. Fine. So it is like just solving. See, you need not use any Kramer's rule here. Fine, Kramer's rule was not at all applied. You just only try to solve it by using the given equations. Okay. So please try to understand. Here it is the same process, but what is that going to happen is your super node got changed. Fine, your super node was in that particular, your super node was, I considered A, B, C, D. So your super node was C and D was your super node. Fine, but here A and D is my super node, and always first you're going to construct an equation for super node first. So in this particular type of problem, try to construct equation for the super node first, and then construct an equation for node that is a single node, and then construct an equation for the voltage that is present between two nodes, that is this VA minus VD is equal to 6I1, and then try to find out where is your I1, here is your I1. Please see the direction. If it is like this, then it is from B to C. From B your current is coming to C. If it is this direction, from C your current is going to B. It is not C and B, if it might be anywhere, so you are going to consider that particular. Okay, so you are going to consider like that and do this particular, do solve this, and you are going to get this resultant, and then come to till here. This one we have only done, why? Because we have got our second equation as two variable, and we are making sure that your third equation should not be a three variable equation. If the variables are, number of variables are different with respect to two equations, you can't solve. You can't solve a two variable and a three variable equation, right? You can solve only both the equations should be two variable, or both the equations should be three variable. Like that you're supposed to solve. That is why we made this into two variable equation, wherein this one became two variable equation and this one become two variable equation. And now we try to solve this, wherein we got this two resultant, and we substituted this in equation number 3, we got this VA resultant. Fine, yes. So now please do try to solve this problem without fail. This problem is also important for exam, so please to solve this problem without fail. Okay, I just taught it you all the things in a clear manner. I guess I've already told these things, but this problem was something different, so I just thought of teaching this because this was not under Kramer's rule. Last problem you could have solved using Kramer's rule, but this problem it was not, so that is why I taught you how to do this. Okay, and I also told you I have done each and everything step by step. Why I have done each and everything step by step, I'll showcase to you now, just a minute. So see here, you can see, make a comparison with mine and this particular textbook. So see here, I have written the same equation. See this VA minus VB by 2 plus VA by 2 plus VD minus VC by 2, which is equal to 3 VC. See here also I have written. See VA minus VB by 2 plus VA by 2 plus VD minus VC by 2, which is equal to 3 VC. Fine, but it's done each and everything directly, but here we have tried to solve each and everything in a simpler manner. See how much steps we have done to solve this. He had finished in how many steps? 1 2 3. He had finished in 3 steps, but here we have done each and everything in a simplified manner. Fine, we are telling each and everything separately. See, we have written 0 VA by 2 0.5 VA minus 4 plus 0.5 VA, and this VD by 2 minus VC by 2. All these things we have done in a simplified manner. Fine, so in the textbook he might give things directly, but please do try to do it in a simplified manner. See here, you can see that it is VA by 2 VA minus 8 by 2, this is plus VA by 2, this is VD minus VC by 2 is equal to 3 VC. Now directly he wrote that VA plus VD by 2 minus 7 by 2 VC, which is equal to 4. Fine, so he's telling you directly, but he's not telling how VA came into existence. We are telling that this VA by 2 0.5 VA and this VA by 2 0.5 VA, this 0.5 VA plus 0.5 VA is making me VA, right? I'm telling each and everything in detail, so please do try to follow our videos and like, share and subscribe to our channel so that you get more and more videos on our on about this, and you're also going to get more and more updates. By what I can say, you're going to press the bell icon so that you get more and more updates. So that is why I'm making you clear, we are going to teach you each and everything from scratch to advanced, because in the textbook if he gives you the answers directly, if he try to give you the answers directly, so sometimes many people will not understand how did this come or how did that come, they'll think. So that is why I'm telling you to please to watch your video so that you get to know each and everything clearly and you don't get into any confusions. And thank you.